Okay, wait a second, I have to put it on.
So Patricia, what is your role at Intel? Are you in software or are you in hardware?
Yeah, I'm a software developer.
Wonderful. So for everyone on the call, while she's getting ready, we were checking back on item number 9 on the meeting notes, the Intel SciThrift PTF and extension to SmartNIC. We thought we'd check back in late January to see if we could extend the framework to work with a SCI device. So that's the what we're going to talk about here.
Okay, can you see my screen?
Yeah.
Okay, so hi, my name is Patricia, and I'm here to tell you something about SCI PTF. So in general, what is SCI? SCI, which means Switch Abstraction Interface, is a standardized API to program network tables. It is an open source, and independently of the vendor, it can control switching entities. Here you can see that it's below network operating system and just above the switch ASIC. So the standard C AP calls the switch abstraction interface, which then calls the vendor specific calls. There is something called PTF, which stands for Packet Testing Framework. It is a Python-based data plane test framework. It's based on Python unit test, and it is using SCAPI to create and send packets. And in the picture, we can see some examples of what packets can be created, like here, TCP, TCP/v6, UDP, and others. And here you can see how we can verify the traffic, like if there is a packet, if there aren't any packet, and stuff like that. SCI PTF is connecting these two components all together, the internal framework for setting the SCI functionalities and the set of functional tests. It uses PTF to test our SCI implementation on the top of switch API. It verifies the correctness of switch behavior, and it also verifies the SCI interface implementation. As it says here, this can be executed on both hardware and model. Like for us, it's Tofino model and Tofino switches. And here's the diagram showing us the components of a Tofino switch. Control plane is the switch or the network OS. SCI is the switch abstraction interface layer, and BMAI is the switch API that we have implemented. The thing that we focus on are the blue parts and the violet parts. Normally, SwitchOS, in order to set something on a device, calls SCI functions, which then call BMAI, which programs the P4 tables. And in SCI PTF, we do the same, but we don't directly call SCI functions, but use RPC. The black line is the call via RPC. Our framework provides it in order to be able to run Python tests that then via RPC call the SAI. Okay. As the slide here says, the most part of the framework is auto-generated. It consists of several things like SciThrift, SCI RPC server, SCI adapter, and SCI base test. First 3 files are auto-generated. SciThrift contains SciThrift definitions. SCI RPC server contains the implementation of functions we can call from the SCI. SCI adapter contains wrappers for RPC server functions. And Psi-based test contains the basic initialization of and command test configuration. How do the tests look like? Each test is a Python class with common configuration for all its subtests. It has to inherit from one of these classes, Psi helper base or Psi helper, and has to follow proper convention with the setup, run test, and tear down functions in order to be able to run it correctly. So according to what I said with previous slide, tests have to inherit from one of these two classes, Psi helper or Psi helper base, and Psi helper base just initializes the switch and stores some of its attributes, and Psi helper inherits from Psi helper base and provides additional configuration. As you can see here on the left, we use 32 ports in our configuration, and mostly all of the tests that we use in this config are then used in tests. So our framework is prepared for a different number of ports, but unfortunately the tests are not. So if someone needs a different number of ports, like if someone needs more ports, then it's okay, it's easy to do. But if someone needs less ports than we use, then probably the tests couldn't be executed as they are today. So if someone needs a lower number of ports, then it would require to adjust the tests accordingly or write a new set of tests basing on ones that are already there. But this is only about tests, because the framework, as it contains the class Psi helper base without any configuration, can be used for any number of ports that you need. This picture presents the test execution. Firstly, the test runs is being run via script, which the test via the script, it calls the functions that are in Psi adapter. These are the wrapper functions in Python. The Psi adapter then via RPC calls strict RPC server, and the server calls Psi functions from the Psi implementation, which then call the actual switch API. So the blue part is the Python test that has to be written manually. The green parts are the parts of the framework, and they are auto-generated. And the orange parts are Psi and switch APIs, which have to be implemented for a specific device. And this is more simplified diagram of the test execution. A test calls Python wrappers in Psi adapter, and then it calls the RPC server, which then calls Psi implementation. The left part could be a regular server. In our case, it is connected to point-to-point with a Tofino switch. So here there would be a Tofino switch or other network device, and here you would have a server, for example, with Ubuntu or something that would be able to run the script with tests. And that's basically the most general overview that I have for today.
Yeah, thank you, Patricia. Silvana, you have a question? Maybe we can take that first.
Yeah, I was just trying to understand the more high-level picture. I think I understand well what Patricia said, but how does this, and maybe I missed the first couple of minutes of the meeting, so maybe that is the reason, but how does this relate to what, for example, Chris has presented in the past in his diagram? Is this an alternative? Is this an addition? I just trying to understand how it is positioned.
Yeah, right. So what Chris presented actually exactly what this is. This is in just a little bit more detail on what it entails, basically the framework itself. the SciPTF test framework and how it is, used on the client side and what is needed on the server side, and the test cases themselves. Yeah, just to double click on what Chris had presented earlier.
Okay, thank you.
I think Chris has his hand up.
Hi, Chris. Yeah.
Patricia, thanks for that overview. I guess I had a few comments. One is, Rashma, could you enlighten us on this framework is for standard Sonic, and I know you're going to do some work to extend it to handle the Dash APIs. Can you talk a little bit about that?
Yes, as Patricia presented, I think that the framework is there, and then that's already being upstreamed to Sonic Sci. And to be able to use that framework on the SmartNIC side is definitely possible. It would be mostly seamless. The second set of items would be the test cases themselves inside of the framework. And the test cases that we are upstreaming right now are geared towards a switch-like scenario, which takes, full Sonic community test requirements, which has 32 ports, etc. And that's how the tests have been written for all the underlay features, as well as some of the tunnel features. So our changes to bring this into the SmartNIC side would be to, not have the assumption of the large number of ports, because the SmartNIC side, it's best if the test actually takes the input from the user. So that's something we are looking at. We have, identified sort of from very, very high level the changes that are needed. And we are looking at the resourcing within Intel. Yeah, we may have made some progress there as well.
Okay, thanks.
I think the most important thing is what Chris mentioned last week, is that the tests themselves can be written independent of the tools,
Yes.
and that you compile from that into the tools, and therefore we can compile it to exercise the northbound interface or the southbound interfaces, etc. So as long as we continue down, so that Chris and others who are working on testing continue to write the test while we figure out the details of how you integrate those tests.
Yeah, thanks, Gerald. If I could expand on that a little bit, and appreciate the support. So I'm proposing that we write test cases in sort of an abstract format. Andy, your comment is precious. We write them in abstract format, so it's somewhat independent of the, let's say, the data plane API, whether it's a northbound or southbound interface, and even the packet generation framework. And that's kind of an aspirational goal. I recognize that there's already a lot of investment in this PTF framework, where it's a little bit more concretely bound to the API, which is Sci Thrift, and also the packet generation framework, which is in this case SCAPI. So there's probably a large body of work that will remain as it is, because it's already a huge investment in testing like the underlay features through a Sci data plane. And I'm not proposing that we, not use that investment, but I think going forward for newer features, especially when we get into the overlay, we might want to investigate a more abstract way of representing test cases and decoupling it a bit from the data plane and also from the API, and have a layer in between that takes a standard test case, like here's a bunch of ENI mappings and here's some tunnels, and apply them in a way that can be done through any northbound or southbound interface. And so that's something Keysight will be spending time trying to come up with others' help as well. But to get more specific, we have created an open traffic generator data model for packet testers that can be used in both software and hardware-based packet testers. And I talked about this before in the group meetings, and I've also documented it in the test high-level documents. I'm going to just paste a couple of links here in the chat that people can look at. It introduces this concept. And we're going to be going down that path for new tests. So I encourage people to learn a bit about it. But in a nutshell, you can write tests using an open data model. That's a community repo called Open Traffic Generator. And we have wrappers with simple Python clients where you can control traffic generators that are either software or hardware based. And it's vendor neutral. So that's the path we're going to go down. And I think these two paths can be complementary and both be applied to Dash. So,
Chris, there is one thing that I don't understand. You said that you want to write this test in an abstract model that will work both on northbound and southbound API. Yes. My impression was that the northbound and the southbound API have two different level of abstraction, because in the middle there is this bluebird thing. So if the level of abstraction are different, how can the test be the same?
The test won't be the same. The representation at the highest level could potentially be the same and translate it into the appropriate interface through a wrapper of some sort. Now this is an aspirational. We don't have working demonstration of this, but this is the approach we'd like to take. And so, for example, if you have a data model that says, here's a routing table or here's a list of ACLs, those can be represented in some abstract way and then translated into the appropriate GNMI interface once we have that data model, or it can be translated into SCI table entries. Right? If they're all ACL rules, the content is roughly the same. Now, if there's some much higher level abstractions, then we have to, maybe they'll only apply at one interface. So it's an aspirational goal, but I don't think anyone would disagree. It'd be nice to write the highest level test case once and leverage that across different interfaces. So that's the goal. And I think it's a work in progress.
Definitely should be the goal. Yeah, that should be the goal. And let's see if we can achieve it.
Yeah, it's aspirational at this point. Hopefully we can have some actual demonstrations of that sometime in the future. And you know, there may be some creative collaboration on coming up with a data model and the wrappers that achieve that.
Thanks.
Yeah, thank you.
So Christina, if there is no other question on this, then we can move to a different topic. But I think
oh my gosh, I was talking on mute. I'm sorry, I was talking on mute. I was asking, is there a time we should check for the customizations for the NIC versus the switch in the project?
Yes, sure. We can. I will discuss with you offline on that timeline.
Okay.
But it would take, we can start with the underlay features, of course, and the most critical ones that we can identify that we have to take up for this effort, and then incrementally add more test cases that we would like to move to SmartNIC. And then we have made some progress in identifying the resource, but we'll, update you offline on that part.
Oh, thank you so much. Great. I was hoping
Hey,
to move.
Reshma, sorry, just a quick question.
Yes.
Do we already have a repo on GitHub which has all this information that was shared today, as well as all the,
Yes.
the framework and the test cases?
Actually, yes. I can paste the PR here in the chat. Or Patricia, if you like to paste the PR, that's fine too.
Yes,
Yeah, we
like,
can.
Is that
now,
the
That'll be
same
great.
PR as before, Reshma? Is that the same one that's in the meeting notes, or is it different?
Yes, I guess, yes, that's the same one.
Okay. Yeah, go ahead and post it, Patricia, and then I'll just make sure I have the
Okay,
same one in the meeting notes.
For now, there are a couple of
Sure.
pull requests. First pull request contains only the framework and general information about it. And then there are more pull requests. You can find them all in this repo. Not all of them are merged yet, but they all contain the tests that we have. There's one pull request per feature.
Okay.
Great. Yeah, thank you.
Thank you. I was hoping to move on to Marianne. We were going to check back regarding the publishing code to the BMVV2 for the dash model and the simulator next steps. Mariam, were you ready to go?
Oh, Christina.
So I don't say this week because we only hired a new person that will help me with that. He's starting to. So it will have to be delayed for another couple of weeks.
What's his or her name?
Milind, he is not here, but we are only doing a ramp up right now, and he will start on this task. So we currently estimate it's going to take like 2 weeks.
Gotcha. Okay.
Question?
Christina, I had one more also when I get a chance.
Go. Go ahead.
Which there were two.
Go ahead.
Okay. Regarding the previous presentation with the PTF framework, just to point out that those tests in that framework uses SCAPI, and SCAPI is not a line rate packet testing framework, right? It's a Python library, and so it's going to be pretty limited in terms of line rate, and it's really a software kind of thousands or maybe millions of packets per second, but it's not 100 megabit type speeds. So that's another reason why the Open Traffic Generator framework is being proposed, because this really goes up to any line rate commercial testing speed. And even with a software NIC based tester, it can run, tens and tens of gigabits per second. So these PTF tests are sort of functional tests where you can send some packets here and some packets there, but I don't think it's intended for line rate. If anyone, if I'm wrong, please correct me. Just want to make that last.
Yeah, that's correct.
Yeah. Okay.
Yes, I agree. The main reason for this PTF framework and test was to test the functionality and to test possibly all available SAI attributes. So we were focusing on the attribute coverage, not on the performance.
Thank you. Thank you.
So one aspirational goal, guys, that I have is that at some point in time, we want to actually to be able to test in the cloud. And so where we can spin up instead of having one VM stimulating the software version of this, we could have like 100. So I do want to make sure that we keep that in mind, that when we're building this framework, that we think about if we moved it to the cloud, we could make it as big as we want and as wide as we want. And we can have as many VMs as we want to create tests. So just keep that in mind when you're thinking about how you want to write these, the framework itself.
Yeah, Gerald, thanks for that. That's kind of a lead in. We're actually working in some engagements where we're doing that with our software traffic generators, and we're gaining quite a bit of experience with that.
Yeah.
And so we can definitely pursue that and welcome some brainstorming sessions on that.
Right. So Gerald, you have to go soon. Is there anything you want to talk about before we move on to Andy's question?
No, and I will have to go. The only thing is that I would like people to consider participating directly with the test group and make sure that we're not all watching. Like there's people actively contributing their engineering might behind this. So I really encourage people to get involved. And I remind you, this is not a Microsoft effort. This is a community effort. So we would like the community to be super involved in, but at the same time, Microsoft's going to deploy this. So the faster we get there, the faster we'll deploy. Dash is, in our future, and it's just a matter of time now.
Okay.
So I need to go, but this looks fantastic.
Thanks,
good work,
Gerald.
guys.
Thanks.
Thanks, Gerald.
Thanks. And, guys, tracking work item number 3, where help is needed, if any of y'all can help, would be the pipeline directory to-do list number 3 from NVIDIA. It's posted in the meeting notes, and I'll resend that when I collate the meeting notes again. Andy, why don't you go ahead?
Thanks. I just wanted to ask if Marian mentioned someone coming up to speed on their side for potential BMV2 enhancements. I'd be curious to hear maybe just a sentence or three on which particular enhancements you think that they're working on first. And Marian, please feel free to contact me, offline outside of this meeting via email or however you wish. Near and dear to my heart to get BMV2 enhanced for things.
Yes, so we're starting with not BMV2 directly, but with the translation side before runtime to be able to configure the simulator. That's the first step because we have this missing, and only after that we will be looking at the items related to the BMV2 itself, like functionality that is missing. For example, connection tracking. But for now, we still have a missing glue layer from site to P4 runtime.
Thanks.
Okay. And you guys have each other's email address, I assume.
Oh, we know how to find each other.
You know how to find each other. Right, right. Okay, all right. Well, so Reshma, Patricia, thank you for the presentation. That's fantastic. I wonder, would you guys mind if we share the documentation we've been working on, or is there a different topic you'd like to cover? Or we could look at the PRs. I'll just share my screen here.
Yeah, that sounds fine. Sharing the documentation is fine. Thanks.
Okay. Does that work for the rest of you guys on the call?
Yeah, that's fine. Christina, one quick thing, just a reminder for all the participants here, if they're not talking, if you could please mute, because there has been quite a bit of, noise. So appreciate it.
Okay. I will make sure I go on mute. I'm in a silent house pretty much, but you mean the bandsaw in the background?
Yeah.
Okay. All right. All right. Yeah. So Michael and I have been, Michael Miele and I have been working on documentation. We've put it here in the pull requests for building out the high level design for Dash here. And we did see some of this work last week, some of it, but we've been, we're always changing it. It's almost like a living document. So let's see here. We found. So again, work in process. I've been working with the Sonic team to more clearly explain as we're moving on in the development of the project what we're trying to do. And so we're creating the text here to read through. We're creating some very high level designs and containers. And again, if you have comments or if something's not clear, please just make a suggestion and we can take it back and incorporate it into the documentation. We do assume familiarity with the Sonic architecture because we're basically adding, a user space container. So if there are questions, please throw them in as suggestions or questions. We talked about the Sdn Controller a lot last week. So we put together a blurb here about the Sdn Controller and then the Dash container here. So we've fleshed out this piece and also talked about multiple DPUs per device. And we've talked a bit about the SI. And so long story short, we're just filling this out as we're, moving forward in the project. And you've seen these where we have the single DPU on the NIC here. And then we have the appliance architecture with the high level, this is presenting as an appliance with all the DPUs. And then the low level, where it works with Sonic and the Dash container here. Hope I'm not going too fast. And this is just a regular, to be clear, this is just a regular Sonic Tor inside of a 42 or 48 RU rack that sits with the two servers that hold the 6 NICs apiece. So this is not a smart switch here in the appliance scenario. This is just a Sonic Tor. And then we move to the smart switch architecture here, where we have the smart switch running Sonic, and then the DPUs here with Dash. And then moving down, we're still working on this part, but we're fleshing out more of how we're thinking it will work. It's going to work with Liwa, Gohan, and Sunny Prince are helping us improve this write-up. And then I had placed in here just a representative region and data center design, kind of explaining what we're doing, because traffic comes in, comes through the region, comes through the WAN. Eventually you cross a lot of miles and you hit one of our data centers. And in the data center, you know, you'll hit the tier 2, the tier 1, the tier 0, and you hit the server racks. And where you can place Dash would be, you know, Dash on the NIC down here or on an appliance over here. You know, there's a rack with an appliance, or so I was trying, or a smart switch, you know, anywhere in the data center. So I was trying to convey that you could place this, you know, at different locations within the data centers. And then that's the end of the run through here of the high level design. We're sitting in a PR request. So any comments would be appreciated. And then we also have, based on our conversation last time, I went to the wiki and started filling out the glossary, and so more of the definitions here and the frequently asked questions. So I've been adding to the frequently asked questions down here. You know, for example, in a switch, why are we not using the CPU? Do we have a list of items that need offloading, blah, blah, just stuff we talked about last time. We incorporate what we take from these meetings and try and put it back into the repo. I'm going to stop now and ask if there's any questions.
Yeah, thanks a lot, Christina. One quick thing that, you know, maybe it's worth mentioning as we talk about multiple different use cases, you know, especially saying which place in the network the dash is used. And as we have heard in earlier meetings, you know, some priority part, right? Saying that, okay, you know, currently we are essentially looking at the smart switch use case first before we look at other things. So I guess it you know, just to really reiterate that, okay, you know, as a community, we'll be focusing on one thing first before we get to the other ones, right? I mean,
right. And Microsoft, we're focusing, Azure's focusing on the appliance right now. Like that's our main focus. We don't have a supplier with a smart switch existing now that's, you know, doing this type of work. So we're focusing on the appliance.
Oh, I think this is different than what we heard.
In 2023, there may be a smart switch.
Oh, I see. Okay, so no, I you know, Christina, like a few weeks back when Liwa and Gerald were basically discussing these use cases, I guess the comment was that smart switch is the first use case that we're targeting. But I'm hearing differently right now that, okay, it's appliances, which is
so what we have right now is, you know, we have racks with the appliances in the data centers now, and they're in what we call a canary environment. So there's a certain number of racks, and we're working to do the offload and the acceleration, you know, for, we call it private preview and public preview for a certain subset of customers. And that's in a project just for offload and acceleration. And then Dash builds on top of that, where we have the API to program the interfaces agnostically. And so we do have, like I said, the appliance with the cards, and we do not have Dash though. It's just a proprietary programming right now. Is that helpful?
Yeah, I mean, I guess I just want it if it is proprietary for now, I guess as a community, what are we targeting first? I guess that will be the question.
So from my perspective, I would, you know, whether we're programming a NIC, an appliance sitting inside of a NIC, or a smart NIC sitting inside of a smart switch, to me, it's
sorry, Christian. I think the you know, I think we you know, we outlined the architecture, you know, for the for this SDN appliance deployment, as well as you know, the smart tool deployment. So you know, you can see in terms of architecture, they are very aligned. So therefore, you know, what we believe that, you know, when we first do the development, right? So you know, the software will be able to target for both. So therefore, as soon as those tools available, then we can start testing the software on top of those tools as well. Right. So, because I think, on us, we're focusing on the software, the size, all those, define this activity, which can be used for both deployment type. Does it
Thank you,
answer your
Gohan.
questions? Yeah, Hanif.
Yeah, it does. I think, but obviously, one thing is we are working on the software side, but another thing is basically, testing as well as, qualifying a certain solution.
Yeah.
And then obviously, everyone here, as Gerald also mentioned, if Microsoft has a plans to deploy something, then people can prioritize one versus the other based on what is the the initial goal is, for example. I mean, we all understand that we will be doing, and then a lot of things are applicable across architectures, but it's just about testing and really devoting the resources to one use case versus the other, right?
Yeah. I think to address that, right? So I think we're trying to work with the hardware vendors, to because so far right now, so we didn't really have a such kind of smart door with those advanced programmable chips embedded with the switch ASICs, right? So I think as soon as we have those, or anyone has any plans to build such things, I think we can engage the offline with Microsoft and see how we can also be working on those projects and right, so to cater for deployment. Yeah, so
sure
those things.
Sounds
yeah
good.
So yeah, but I think on this forum, I think, right, so everybody here, so we discuss all this the common software architectures, ensure that the same software will be able to run on both on different deployment type. Because I would imagine, even in in our in the cloud deployment, right? So because different deployment have a pro and cons, and there are various different scenarios we need to take. So I would imagine both such deployment could coexist, right? So therefore, we are trying to create this common software architecture that allows us to run, meet our customer needs for both of these deployments.
Sure. Yeah. Thanks a lot, Gohan. That explains. Yeah.
Thanks, Gohan. And Chris, I was wondering if you wanted to present your improved testing workflow towards the end of the call here.
Yeah, and also the dash testing maturity stages.
Yeah. Yep. Great.
Do you want me to do that now?
Yeah.
Then?
Yeah.
Okay. Let me get my screen ready and I'll get the right things going here.
Okay.
Give me a second.
Christina, while Chris gets ready, we'll have 5 minutes to discuss what it means to be Dash compliant.
Mm-hmm. Sure. And Gerald had mentioned we that's really like our community definition of what that means to be compliant. So, if we have ideas, we can document it in the repo.
I sent an email to the mailing list. I don't know if you saw it, but basically,
of course I did.
Basically, this is a much more complex project than a standard. In a standard, you develop a protocol and you say, okay, you are compliant if you implement the protocol. Or you develop an API and then you see you are compliant if you develop an API, if you comply with the API. Here it seems to me that to be compliant with Dash, you need to do major activities in different fields, and I would like a document that lists that activity. The four that came to mind to me is basically being compliant with the Northbound API or GNMI, being compliant with the Southbound API, being compliant with the P4 mode, and running some version of Sonic. And I even don't know if that is all what is required to be compliant. Do we agree that all that things are mandatory? Is that the definition of a Dash project?
It sounds like it's a good list to me, and I'd welcome collaborating on starting on like an HLD for the high-level test requirements. If nothing else, we can put something out there and get reactions, right, and then make it better over time.
Absolutely. But I don't know if anyone in the group has something that immediately come to mind that need to be added or something that they don't think it belongs.
I think there's a whole high availability set of requirements as well.
Oh, I forgot.
Yeah,
John, we have a PR out
Right.
for the HA document. I totally forgot that. Yeah.
Right. So that would also be required, right, as part of Dash.
Got it. Okay. Chris, are you ready?
Yeah, what I'd like to do is show the Dash testing maturity stages.
Sure.
Is that okay?
Yeah.
Yeah. Here, how to share my screen here. So let me know you can see my GitHub screen.
Mm-hmm.
Is that showing?
Yep. Yeah, you can see it.
So this is a list of open pull requests, and the one I'm going to talk about is this one right here. And what it is an attempt to show different testing scenarios of a single card, and we can enhance it over time. I'm trying to show it two ways. One is bottoms up testing the data plane, starting at the, let's say, what we've talked about now, Scythrift, traffic generator, basic interface, like the lowest data plane layer. And what I'm trying to do is show us a progression starting from what is probably what's happening in some cases right now in different providers' laboratories, and even in our laboratory where we have proprietary tools on the device. People are using handwritten tests and getting things working, kind of bootstrapping themselves. It's sort of, I call it manual or ad hoc testing. To me, the next stage, and working our way from the bottom up, is to get some standard test cases using some kind of standard API. And this might also be augmented by the Scythrift tests that we saw with the PTF. The next actually, that's the next stage where vendors have implemented the Sci library on their device, and now we can have truly standardized Dash Sci API tests. So this would be Scythrift. And this is kind of the common meeting ground where we first have some kind of a Dash compliance API. Now I want to propose also, this is something that PL Vision, which I believe we have some PL Vision folks on the call, they developed something called Sci Challenger, which has been offered to OCP as part of the Sci repo. And this is using the lowest part of the Sonic stack, which would be the Redis database, ASIC-DB, and the Sci Redis library. This basically also exercises the Sci library, but you're also getting parts of the Sonic stack integrated. And this level of this abstraction here is easy to work with. So it's like the next step towards integrating with Sonic. First, you just have Sci, libsci here with Scythrift, and then you've got parts of Sonic. So we're going to be exploring this as well. This is another level of integration, get you ready to integrate with the rest of Sonic. And then at some point you make the leap to, I need to update this because this would be the, what we call, has been called the Dash container. This is a GNOI server with schema that Michael Zygmunt said he's working on and will be releasing maybe late this month or early next month. This is where you actually have the Sonic Northbound interface. So at this point, you've kind of gone all the way down through all the layers. Now that's starting from the lowest data plane level and going all the way up to Northbound. And this is just a single device. Now I flipped this whole thing on its head.
Chris, what is the advantage of the previous one?
This one.
I don't understand that. Yeah.
The advantage. One of the advantages is you're getting integration with what eventually you're going to have to integrate with Sonic anyway. So you're getting integration with Sonic at just the ASIC level abstraction. It's still Sci type objects, but you're integrating with Redis and with a lot of this infrastructure, this messaging and pub sub infrastructure. So it's integration without worrying about other parts of Sonic yet. So
yeah, I'm not sure I see this. I mean, if I port Sonic, I port Sonic. Otherwise I need to develop another interface.
Not necessarily. If the test case is written in terms of Psi objects, then that can be translated into Psi Redis or Psi thrift. That was one of my points I made earlier, where the test.
Okay, let me reformulate the comment.
Sure.
I am perfectly okay on that. I would like to basically understand which stage are mandatory and which stage are optional.
This is not. None of these are mandatory per se, but I would say this one. This is like the minimum integration point with Sonic. You have to have a working libpsi, right? And you need to be able to prove that psi works.
Yeah, you see, this go back to my question of compliance. Which test do I need to run to be compliant? Because that one I want to be sure I support. The other, if they are convenient for me to do or not, I'll decide when I do it.
Yes. Okay, thank you for putting it that way. I wrote in this document that this interface is the minimum one to demonstrate. And now I think that's for the community to jointly decide, and Microsoft probably has a strong opinion on this. But this is I think I would call it a convenience, but it may become very compelling convenience. But this is definitely probably a conformance requirement. And so does anyone have anything to add to that or inject? Does Microsoft have an opinion on this? So far, this has been the, interface of record.
Right. Gohan or Prince, that's what we've been talking about, right?
Yeah. So that's been working with on the side for the qualification part, the side shift, right? So.
Yeah. And I stated here, stage 3 duct configuration via SideScript is deemed the minimum gate for dash performance and conformance testing. So that was my proposal, and I think we've basically come to that conclusion. And I think stage 4 here is, I think when we get to that point, people will decide, what works for them. I don't think it necessarily is a conformance test, but as Gohan has alluded in the past, this testing diagram was based on a lot of hard experience in integrating Sonic over the years, and that trying to do the whole shebang at once was painful to try to debug and isolate. And so this gives you a look at the data plane without everything else. So you can really focus on getting that correct. Because, the industry has learned that most bugs found in a running Sonic system usually get isolated down to this layer a lot of times, and it takes a long time to get to that point. So we want a simple test environment that exposes that as soon as possible. This, I think.
Chris, just a quick question on these stages, right? It's stage 3, 4, and 5.
Yeah.
As you show these data-driven automated tests, since the interface is different, right? Whether you are calling SideThrift or SideRedis or in the in the site, those tests and those calls will be different, right? I mean, we just need to highlight those ones because they all say data-driven automated test, but they'll be different, right?
Well, certainly what you'll see on the wire is going to be different, but it's possible that a declarative test case would say, for example, here's 3 ACL table configurations. Apply a bunch of traffic and prove that it works correctly. Those ACL tables could be written, I'm just going to say as an example, a JSON file that can be translated into the equivalent SideRedis configuration, the equivalent SideThrift configuration, or even the equivalent GNMI configuration, if they're really abstracted from, let's say, any one particular schema. And that's the aspirational aspect of this, that, it remains to be proven if that can be done successfully, but I'm certainly going to try hard to do it. Because then the test case is true no matter which interface you're using to program the data plane. Ultimately, the same thing goes into the chip, right? So the contents of these test cases at some level, there should be some common ground that can be translated into the let's say, the transport. Does that make sense?
Right. Yeah.
I mean, instead of saying, here's a literal list of psi objects that I'm going to apply as my test case, it could be, here's a list of ACL entries, IP addresses, masks, rules, actions. Those can be translated into their thrift form or their GNMI form if the test case is the same. And that's an exercise for the reader, so to speak.
Right.
What I wouldn't want to see is someone translate 3 ACL tables into manually. Here's the literal contents in psi, here's the literal contents in GNMI, etc. manually, because it's very hard to generate many test cases when you have to manually create each one like that. Let's have one common single source of truth and then translate it. It couldn't even be a program that generates the 3 different forms, right? Python script or something. So that's the hope.
What still concerns me is if I run a test and stage 2 pass, but stage 5 doesn't pass, and I have a conflict, then I'm a bit confused, because if one pass, the other also should pass. Or otherwise,
it may be a bug we're in this stack, right?
Since I have no full control on the stack,
right?
That is the other part that I'm confused about.
Well,
I'm confused about who is in charge of a mapping between the northbound and the southbound.
All right, that's a really good question. Can we post that for just a moment? I think Microsoft will probably answer that question. I want to just show also real quickly the top down, and maybe that'll help answer your concerns. Here's taking the whole same test flow, but doing it backwards, starting from the top. GNMI schema, writing tests to a dummy implementation, and then applying it to and then having it go into the AppDB of Sonic and verifying that the contents are in there. Then verifying the orchestration daemon translates it into their ASIC contents. This would be the responsibility of someone writing Northbound, for example, making sure it works its way down. And finally, getting into a fake psi library. So this is purely a software exercise, verifying that all these stacks work. And finally, getting down to the same stage 5. It's the same in both cases, the actual integration. So it allows developers who are working on the data plane to work from the bottom up, and allows the, let's say, the network management and higher level stack to work from the top down. And at some point, you resolve problems. Does that make sense? I mean, it's just a software development progression, so that it's not, you're not waiting, each party's not waiting for the other to be ready before you can do your work. You can make progress on your way down, from the top down, and progress from the bottom up, and then we meet in the middle somewhere. And these are just conceptual stages. It's like a vocabulary to describe what's going on. It's not a prescription, here's how you must proceed. That was my hope, to get the conversation.
No, this is great. Yeah, thanks, Chris. This is awesome. This really describes it in full. And then, just to answer Silvano's, question, right, in terms of, org agent, org agent daemon that is described here, it's a translator, as we have actually seen. It's the heart of Sonic. Okay, it's really the heart of Sonic, and this is where the entire, when we say heart, really, we mean it, that this, without it, Sonic is not there, right? But at the same time, in order to really get everything working, this is a big piece of work, and then this is also can basically become complex, as well as also, if not done right, may not scale well also, right? So, there are a lot of challenges there in order to make sure that we get the org agent right. But having said that, I think the stages that are defined previously, like, third stage or even second stage, those are very important to really, isolate the issues and getting that right, so that we only focus on org agent once we come there, and then start to do all the things that we want to do, like both dash agent and org. I mean, in this case, GNMI server is essentially the dash agent, and then the org agent is essentially the ones that essentially translating from the southbound that it is getting into the ASIC DB and eventually driving it. So from the perspective of really, unit testing different pieces to ensure that, okay, we have really solidified them, I would start, second or third stage and really make it solid before going down into the one below.
I had a different understanding. I understood from the previous meeting that the ARC agent is only a small part. There is also all this Bluebird agent that need to be ported.
Yeah, this.
Maybe we
And
could
most
get
of the
maybe
translation is done by the Bluebird agent. My
maybe
concern
we
is-
could get
Okay.
Gohan to explain it again. Gohan, do you have a couple of minutes to explain Orc agent versus the Michael Zygmunt's SDN work?
Yeah, I think what happens here, right? So is that this GMI is really providing the northbound of the interface, right? So to the and to the Bluebird APIs, but it's mostly a shim translation layer where it takes the GMI configuration and then put into depending on where where whether they need persistency or not, right? So depending on some of the character properties they need for those objects, then the GMI is going to put those configurations or setups and routing trees or whatever into the database, right? So then the database is going to translate all those entries into the side function calls, right? So yeah, so in this case, we do support the Bluebird APIs, but we do want to keep this this GMI as a scene layer. I think most of the translation logic there for is going to be on the OKG side.
Yeah, I think Gohan, in Christina's dash HLD, we have captured that.
Yeah, okay.
Yeah, this flow.
Yeah, thanks.
Thanks, Prince. Okay, guys, it's 10, and I'm sure you all have a 10 o'clock, and I know I do. So I'll send out meeting notes. And Gohan, thank you for the explanation. Let's anyone who has questions on Chris's test maturity or the HLD, please put them in the GitHub as a comment, suggestion, or something. And if there's other questions, email them in or ping me offline, krisny@microsoft.com. And I'll talk to you next week.
Thanks a lot.
Thanks all. Thanks, Christina.
Thank you.
Thank you.
Bye-bye.
Thank you, Reshma. Thank you, Patricia,
Okay.
John.
Thank you
Silvano.
all.
Okay.
Bye-bye.
Bye, everyone. Thanks.
Bye. 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 מה קרה? נו. אז מה, אז למה לקלח? וואי וואי וואי, אתה כולך רטוב. תייבשי אותו. שובב? למה? הוא צריך להתנגב. תעשי לו פן, למה צריך מקלחת? הם שיחקו יחד? לא הבנתי איפה לקחתם אותם.
Hi, how are you? Elsa should apply to Jeopardy. Please ignore the location, the and description desk. No. You can do location and description. If you need help